now with this supply. So this is a IDMT, sorry, it is not IDMT, this is a directional overcurrent relay. So presently the plug setting, I was talking about the word plug setting. So this is a bridge, this is a bridge and this is the plug. So these pluggings are inserted in this bridge over there. I will show you the markings. The marking was here. So I have inserted a bridge, this plug, the plug setting of 1. So this relay will operate when the current sensed by the relay is more than 1 ampere. I can remove this plugging and insert in different plugs over there, different slots over there. So I can increase the current up to maximum 4 ampere. Usually the relays are connected in the secondary of the city, and therefore the rating of the city are usually either it is 1 ampere or 5 ampere. So presently we are using a 1 ampere relay, and so if you have to implement this relay, the city should be of the secondary rating of 1 ampere over there. So presently the current plug is inserted in 1 ampere. So relay will operate when the current sensed by the relay is more than 1 ampere. Remember, although we have set as 1 ampere, relay will never operate for the current equal to 1 ampere. Okay, the current should be more than 1 ampere over there. So let us start now. So I shall turn on the supply, the switch over here. The switch is on, then the MCB, it is also on in the on position, and directly I am coming over on the table over here. I am turning on the supply. So you can see the light has been turned on. I will first increase the current. This is the dimmer for increasing the current. So current should be more than 1 ampere. I am making it 1.5 ampere. Remember, for 1 ampere relay will not operate or it will take an infinite time. So I am taking current as 1.5 ampere. And let us increase the voltage. So what you are doing, we are increasing the output of the slip ring induction motor, and the range should be around not more than 110. So it should be around 40 to 60. I am making it 50 volt over there. Okay. And I am turning on the CRO. So you can see the two waveforms on the CRO. If I reduce the current for your reference, okay, one waveform has been flattened, and now I am again increasing the current, and so the waveform is increasing over there. Now if you see, the two waveforms are not in phase with each other. So what I shall do, I shall rotate the rotor. This is the rotor. I shall rotate the rotor to adjust this waveforms. So now if you look carefully, the two waveforms are in phase with each other. Okay, and now if you look carefully, the relay has operated over there. This is the disc, the relay has operated. If I reduce the current less than 1 ampere, I will make the current less than 1 ampere, the disc will start in the reverse direction. You can see the disc is rotating in the reverse direction. Presently the current is less than 1 ampere, and therefore the relay will not operate. Again I will make the current as 1.5 and like this. So as soon as I make the current as 1.5, the relay is operating. So presently the phase shift between the voltage and current is 0 degree over here. 0 degree over here. Okay. And coming over here, if you look on the scale, this is my 0. Look carefully, this is my 0 over there. So you have to hold your pen like this so that you don't misplace your 0 over here. So this is my 0. Now what you have to do, the relay will operate as per this characteristics. If you look at this characteristics over here, so presently we are at this position. This is the operating region, and this beside there is the non-operating region over here. Okay, so presently we are at this position. Whenever we are at this position, the relay will operate, and so the relay has operated. So unless and until we will remain in this region, relay will operate. Once we leave this region, relay will not operate. So what you have to do, you have to measure this angle over here. This is the lag side, this is the lead side. Usually, ideally, the characteristics, this characteristic should be perpendicular. First and the fourth quadrant should be a positive region, and second, third and fourth, it should be a negative operating region. But due to the impedance of the pressure coil, as I already told you, terminal number 7 and 8, they are the pressure coil. So due to the impedance of the pressure coil, the characteristics get shifted like this. These characteristics can be adjusted by inserting the resistance or capacitance. Since due to the inductance of the pressure coil, high impedance of pressure coil, the characteristics are shifted like this. If you add a capacitance, it can be adjusted. If you add a inductance, again it can be rotated like this. So we can adjust the characteristics by inserting the resistance or by managing the impedance of the pressure coil over there. So this is the lag side. Lag side is less than 90 degree, and this is the lead side. Lead side is more than 90 degree. So the actual meaning of lag and lead is same. When I say lag, this is current lag. When I say current lead, it is always the current lead. So presently they are at 0 position. The relay has operated over there. Okay, and now what I'll show, I shall rotate the disc so that the relay get reset. So first I shall rotate either direction. First I am rotating in a clockwise direction. Let us see now. See, the relay is getting reset. I am taking again back to the side. So it is getting operated and it has operated now. Okay, again I am rotating in a slow manner. So this is the verge. At this, the relay is getting operated over there. And if you look over there carefully, my zero was at this position, and now I have rotated it in a clockwise direction. The zero has reached over there. So total displacement of the relay is approximate. It is 40 degree. It may vary between 50 to 60. Presently I am getting it as 40 degree over there. And if you look at the waveforms, there is a phase shift of 40 degree. You can measure it on the scale, but measuring on the CRO is a little bit quite tedious as compared to the scale. So we are using the scale for measurement of the phase angle over there. Again, what I shall do, I shall make the current as phase shift as 0. I will come back to the original position. I have come back to the original position. Okay, this is the original position 0 over there, and the relay has operated again. Now what I shall do, I have reached again up to this point. I have moved from this point to this, again back to this. Now I will go in a anti-clockwise manner. Okay, so I am moving the this disc in an anti-clockwise manner, and I shall observe at the position at which the relay gets reset over there. So talk some more again. Yeah, reading is getting reset. This is the triggering point, and after this, relay is getting reset over there. You can see there is a large phase shift between the two angles. My zero was at this position, and I have rotated over here like this. So my zero has gone up to this. So total displacement comes out to be, as per the lower scale, comes out to be 130 degree. It is lower scale, it is 130 degree. So 130 is more than 90, so this is the lead side. So 130 degree on the lead side and 40 degree on the lag side. Ideally 130 plus 40, that is 170. Ideally it should be 180, but due to practical errors we are getting as 170 degree over there. Now what you have to do, you have to measure the MTA. Now what is MTA? MTA is the maximum torque angle. It is the angle between voltage and current. At that position we are getting the maximum torque. Okay, and so the formula for flux is given by phi 1 into phi 2 into sine of omega t plus theta, or omega t. So omega t plus theta. So that theta is, we have to calculate, or tau we have to calculate. So taking the lag side as the reference, this is 40 degree. So taking the lag side as a reference, I am keeping the lag as a reference 40 degree, and then I am drawing a perpendicular over there 40. So this will be 50 degree. So my MTA comes out to be 50 degree right now. If I take lead as a reference, so 130 minus 90, my MTA will be 40 degree. So to avoid the confusion, I am taking the lag side as a reference. This is 40 degree, this is 50 degree. So MTA is 50 degree. So in this way we are calculating, we have seen the maximum torque angle. We have measured the maximum torque angle in operation of the directional overcurrent relay.